working with Le Chatelier's principle. So for this first equilibrium system, if we increase the concentration of the sodium ions, so if we increase this, we're going to shift away from that increase and we're going to shift towards the making of more heat and solid sodium chloride. And the concentration of the chlorine ions will decrease. If we increase the concentration of the sodium chloride, well, the sodium chloride is a solid, so adding more solid isn't going to do anything to the direction of the equilibrium. So there will be no change in the concentration of the sodium ions. If we increase the temperature, we use that as if it is a reactant. We will shift away from an increase, so we will shift towards the production of more products. The concentration of the NaCl will not change because it is a solid. Otherwise, we would expect to decrease the amount of NaCl in the solution. But because it is a solid, it doesn't have a concentration associated with it. If we decrease the pressure, there will be no change. So the number of moles of chlorine will not change. And that's because pressure is going to change when we have is going to change in equilibrium when we have gases, not when we have aqueous and solid components. So in this equilibrium system, if we decrease the concentration of the NO, we need to shift to replace that decrease. So the concentration of the O2 will decrease in order to increase that NO. If we decrease the concentration of O2, again, we shift towards a removal. So the concentration of the NO will decrease in order to compensate. Number 7, if we decrease the temperature using heat as if it is a reactant, if we remove it, so we're cooling this system, then we will shift the equilibrium to replace that heat. That means the concentration of the N2 will increase accordingly because we are shifting the equilibrium towards the production of more of our reactants. If we decrease the pressure, now we have a gaseous system. We have 2 moles of gas on the reactant side and we have 2 moles on the product side. So if we change the pressure, neither side is going to be favored. So we will have no change here. For system number 3, if we increase the concentration of SO2, then we will shift away from an increase and we will decrease the concentration of O2. If we decrease the O2, so we're going to pull that down, then we will shift towards a removal and the concentration of SO2 will increase in order to compensate. If we decrease the temperature, then we will shift towards the reactants. We will shift to the left in order to replace that heat, and SO3 will increase as well. If we increase the pressure, now we have a different number of moles on the reactant side and the product side. So we have 2 moles of gas on the reactant side and we have 3 moles on the product side. By increasing the pressure, we're going to favor the side with the fewer number of moles. So the number of moles of oxygen will decrease. For this system, if we add ammonium ion, then the reaction is going to shift away from the addition and there will be more of the NH4Cl solid created. There will be less Cl- in the system. If NH4Cl is removed, then we will make more of our ions. But we aren't going to necessarily shift the equilibrium because as long as we have solid, adding more solid doesn't change anything. So there really shouldn't be any change noted. If the pressure is doubled in this system, we have 2 moles of gas on the reactant side, 3 moles of gas on the reactant side, and 2 moles on the product side. If we increase the pressure, we will shift to favor the side with the fewer number of moles. So we will create more CO2 and we will have less CO and O2. If we reduce the volume, that's the same as increasing the pressure. So we will have the same shift noted. There will be more CO2, less CO and O2. We're going to classify this reaction as endothermic or exothermic. Here we have heat on the product side. That makes this an exothermic reaction. So if we increase the temperature, we need to shift away from the increase and we will create more of our reactants. Therefore, there will be more N2 and H2 produced. There will be less NH3 in the system. If we cool the reaction, then we are decreasing this product. We shift to replace that heat. We're going to shift right. So there will be more NH3 and there will be less N2 and H2.